Out there, beyond the reach of our fastest spacecraft, beyond the glowing heart of our own solar system, lies a world unlike anything we have ever imagined. A planet where ice does not melt under heat. A planet that burns without fire. A place where the laws of physics seem to bend. This is Gliese 436b, a Neptune-sized world locked in a deadly embrace with its parent star, racing around it in just 2.5 Earth days. Scientists call it a hot Neptune, but that simple name hides the truth, because Gliese 436b is not just another exoplanet. It's a cosmic paradox, and it might be the key to unlocking one of the universe's strangest secrets. The story of Gliese 436b begins in 2004 at the W.M. Keck Observatory in Hawaii. Astronomers had been studying a small red dwarf star just 33 light-years away in the constellation Leo. It was nothing remarkable until they noticed something strange. Every 2.5 days, the light from this star dipped ever so slightly. Not enough to be a random flicker. This was a transit, a planet passing directly in front of its star, blocking a tiny fraction of the light. The data was clear. A new world had been found. But as more data came in, astronomers realized this was no ordinary planet. It was about 22 times the mass of Earth, similar to Neptune, yet orbiting much, much closer to its star than Mercury does to our Sun. Temperatures on its surface were high enough to melt lead. On Earth, ice melts at 0 degrees Celsius. On Gliese 436b, the surface temperature reaches over 430 degrees Celsius. Yet, somehow, ice exists here. How is that possible? The answer lies in physics and pressure. Under immense gravitational force, water molecules can be squeezed so tightly that they form exotic types of ice, like Ice 7, that remain solid even at hundreds of degrees. On Gliese 436b, this means entire oceans may be frozen solid, while literally boiling from the inside. It is a landscape beyond human experience, solid yet unstable. In this burning world, ice and fire are no longer opposites, but partners in a strange cosmic dance. As if the puzzle of burning ice were not strange enough, Gliese 436 beholds another cosmic surprise, an atmosphere being torn away. Astronomers using the Hubble Space Telescope discovered a massive cloud of hydrogen escaping the planet. A tail so enormous, it's 50 times larger than its parent star. The planet's optical transit dims its star's light by less than 1%. But in ultraviolet, the transit lasts far longer and cuts off over half of the starlight, a clear signature of an extensive hydrogen envelope and tail. Estimates place the mass loss at 100 million to 1 billion grams per second, or 1,000 metric tons every second. Over the planet's lifetime, especially during its star's early, more violent youth, Gliese 436b may have lost up to 10% of its atmosphere. This atmospheric erosion has implications beyond this one planet. It offers a window into how some exoplanets evolve, possibly shedding massive hydrogen envelopes and transforming from volatile worlds into bare, rocky cores. Venturing deeper still, we enter the chemical realm, and this planet rewrites expectations. On ice giants like ours, methane is abundant. Yet, observations of Gliese 436b with the Spitzer Space Telescope showed virtually no methane, but high levels of carbon monoxide, a paradox under the planet's estimated 800 Kelvin temperature. The expected reaction leans toward methane at temperatures below 1000 K. But Gliese 436b defies this. Scientists propose two main theories to explain the imbalance: rapid vertical mixing, preventing methane formation, and/or non-equilibrium chemistry fueled by high metallicity, perhaps 10 times solar levels, shifting the atmospheric chemistry. Adding another layer of complexity, observations from Hubble suggest a nearly featureless transmission spectrum, possibly due to high-altitude clouds or haze masking chemical signatures. The most mind-bending detail about Gliese 436b isn't its heat, its ice, or even its atmosphere. It's the way it moves. Unlike Earth, whose orbit is nearly circular, Gliese 436b races around its star in an orbit that is noticeably eccentric, slightly stretched like a cosmic oval. For planets this close to their star, you'd expect gravity to smooth their orbit into a perfect circle over billions of years. Yet here it is, still running like a lopsided racetrack. Why? Astronomers suspect a hidden hand is at play, an unseen gravitational influence. Some theories suggest there might be another planet in the Gliese 436 system, a perturber, quietly tugging at 436b's path, keeping it from settling into a circular orbit. If that's true, then Gliese 436b is part of a more complex planetary family, one we have yet to fully see. But that eccentric orbit does something fascinating. It stretches and compresses the planet slightly during each revolution, generating tidal heating inside its interior. This heating might be part of the reason why the ice remains locked in that strange, burning state, and why the atmosphere constantly sheds material like a comet's tail. Gliese 436b is more than just a scientific oddity. It's a test case for how we understand planets outside our solar system. It challenges the rules we've learned from studying our own neighborhood. It forces us to rethink how atmospheres survive, how heat interacts with exotic ices, and how orbits can be maintained by forces we can't yet see. In some ways, Gliese 436b is a warning. The universe doesn't play by our rules, we play by its. The fact that this small, distant planet can maintain such an extreme and hostile balance makes scientists question just how many other impossible worlds are out there. If this is what we can see with our current technology, imagine what we might find when the next generation of telescopes, like the extremely large telescope or upgraded space observatories, come online. The allure of Gliese 436b isn't just in the numbers or the physics, it's in the story. The thought of a frozen ocean, hotter than boiling water, orbiting so close to its star that a year lasts just 2 days. It's something out of a sci-fi novel. Yet here it is, real, measurable, and defying our expectations. One day, when interstellar probes or advanced observation arrays become reality, Gliese 436b may be one of the first exotic worlds we choose to visit. Not because it could host life, but because it represents the limits of planetary diversity, a world at the edge of what physics allows. So here's where we're left. A world 33 light-years away. A planet where ice is fire. Where an atmosphere trails away like a comet. Where the orbit is bent by an invisible companion. Gliese 436b is a reminder that the universe is stranger than we dare imagine, and that each discovery is just a door to the next mystery. What if Gliese 436b isn't the strangest planet out there? What if there are worlds where oceans are made of molten glass? Where continents float in a sea of liquid metal? Where storms rage for centuries without pause? We've only just started looking. And somewhere, far beyond our reach, another impossible world is waiting to be found.